Okay, Math 2, Unit 9, Section 1. So this unit is all about circles, and before we begin, we have a few definitions that we're going to need to talk about. So we have an arc. An arc is a piece, P-I-E-C, that's not right. I'll say a part of the circumference. If you're thinking about a circle being a pizza, we're going to be talking about the crust. The crust is the arc, the very edge, right? So if we look down here, this piece right there would be an arc. This would be another arc. So arc. Within the realm of arcs, we have major arcs and minor, M-I-N-O-R, arcs. Major arcs are big arcs, minor arcs are small arcs. Major arcs are more than half a circle. And minor arcs are less than half a circle. So one way to talk about this with major and minor arcs is if we've got this circle here, and we say, well, we have a minor arc xu, then we could say, well, minor arc xu also has a major arc like that, going across the rest of it. A lot of the times you talk about your major and your minor arcs as a pair to make the whole circle, right? Because a major arc and a minor arc together can make the whole circumference. So there's that. Next up, we're going to talk about central angle. A central angle is an angle with two edges with, how do I want to say that? An angle where the center is in the middle of the circle. How do I say that? Angle with vertex at center of circle. An angle with the vertex, the middle point, at the center of the circle. All right, I know there's going to be more definitions, but that's all for this section. So, the actual problems. If an angle is given, name the arc it makes. If an arc is given, name the central angle. So one more thing that I've said that I didn't say. A major arc is almost always, I think it will be always, described with three letters. So here we have MKL. We start at M, and then we hit K, and then we hit L. So we have to go that way around. So MKL is a major arc. And it says that they want the central angle for it. Now we could say this piece there, or we could say this piece here. And the more that I look online and I look at definitions, it seems like there's a divide. Some people say that central angles always have to be less than 180 degrees. And some people say that central angles will always be the measure of the arc. In this case, Kuda says the answer is angle 1. So later on, whenever we have more formulas, we're going to have to talk about central angles. And whenever we talk about central angle of an arc, we would talk about this piece here. But if they just ask for the central angle, like in this scenario here, you should look for the smaller one. So I know that's a little bit confusing, but I think with it being multiple choice, you'll be able to work it out. So MKL uses this green angle, angle 1. Number 2, angle 4. Well, that's going to have XU. And that's how we describe an arc. You have the two letters, the two endpoints of the arc, and then you put a little, I don't know what that would be, a little hump on it, on top of it. All right. Number 3, we've got BD. That corresponds with angle 3. Number 4, another major arc. So we've got XVW. So it looks like we're going to have to go XVW. You always want to follow the order that they listed in. So it covers those 3, but Kudo will say that the answer is angle 2. That will be the central angle. All right. Number 5, find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. Now, I don't know that I said this yet, but the arc measure equals central angle measure. So here we want angle BAC. Where is that going to be? BAC. So we want this angle here. In order to do that, we're going to look at the arc. So we're going to have to use some different ideas. We remember that there's 360 degrees in a circle, which means that half a circle, a semicircle, is 180. So a diameter, which this right here looks a whole lot like a diameter, cuts the circle up in half. So we know that, we'll call this x here. We know that 135 plus x has to equal 180, right? Because half a circle is 180, and that diameter, you add those two guys up. So I'm going to take a calculator and solve this. So I'll say 180 minus 135 gives me 45. So x is 45 degrees. Or if you wanted to put it back in their words, you could say, well, measure of angle BAC is 45 degrees. All right, number 6. HJG. HJG is right here. So how do I want to do this? I'm going to erase this. I'm just going to highlight the edge of it. Well, we can kind of see that here's a diameter, and here's a diameter. Vertical angles can come into play here. Remember vertical angles, anytime you have two lines, the opposite angles or the vertical angles are congruent. So this guy and this guy are congruent, which makes this up here 41 degrees. Now if I call my arc HG X, then now I have my diameter here, and I have a semicircle, so I can say, well, 41 plus X plus 94 is 180. So now I can solve that, and I think I get 45 again. 180 minus 94 minus 41 gives me 45. And that's just a pure coincidence that both of these problems had 45 as an answer. There's nothing special about 45. So if I put it back in their words, measure of angle HJG is 45 degrees. All right. Number 7, solve for x. Assume that lines which appear to be diameters are actual diameters. Now on the homework, you're going to have to be careful. Sometimes it will say solve for x, and sometimes it will say solve for the missing angle. So sometimes you will have to just get plain old x, and sometimes you'll have to plug it back into whatever is listed. You just need to make sure that you read the directions and see which one it's asking for. So here, what do I want to do? So I'm trying to find x plus 65. That's this angle here. Well, I have the arc right there. So I know that the angle is equal to the arc. So x plus 65, plus 165 is 160. So whenever I subtract there, I get, well, x is negative 5. Nice and easy. Notice that a lot of these will give you all kinds of extra information that you don't need, okay? Just because something is listed does not mean that you have to use it. Number 8. So I've got two different x's here. I see that this is a diameter. So if I add those two angles, if I add up those two angles, I get 180. So I could say, well, x plus 141 plus x plus 43 is 180. So this is 2x plus 184 is 180. So 2x is negative 4 and x is negative 2. Now also, just like how last time they were both 45, there's nothing special about these x's being negative. It's just a coincidence that they are both negative. All right, number 9. Find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. So here, this is kind of what I was talking about earlier. We have our x's in there, but we don't find the x, we find the angle. So really, it's kind of like a two-part. We're going to have to find our x, and then we're going to have to plug in. So where is UPQ? UPQ is this here. So whenever we're done, we're going to have to plug into that thing there. If I were to draw in diameters here, right there, and right there, then I'd have big vertical angles. I have a vertical angle there and a vertical angle there. So I know that those are equal. So I could plug in, how do I want to draw that? Right there. I could say, well, 11x minus 4 equals 72 plus 5x minus 4. Right? Because I know that those big angles are vertical angles, and then I just added together the two smaller angles that make it up. All right, now I can add those up and solve, so I'm going to have 11x minus 4 equals 68 plus 5x. So that's going to be what? 6x equals 72. And what is 72 divided by 6? That's 12. So x equals 12. When I boxed that, and I almost wanted to be done, but I have to plug back in, remember? So I'm going to have, well, 11 times 12 minus 4. 11 times 12 minus 4 is 128 degrees. So the answer that Kuda will list will be the 128. All right, next up. So I'm trying to find UV. That's going to be this here. So I know that after I find my x, I'm going to plug into x plus 91. Again, I think I'm going to be able to use that same trick with the diameters and the vertical angles. Here's a diameter. Here's a diameter. So I know that this guy and this guy are equal. So I can say 135 equals x plus 91 plus x plus 56. I added up two different angles there to make the 135. So I've got 135 is 2x plus 91 plus 56 gives me 147. I subtract 147 from both sides and I get negative 12 is 2x and x is negative 6. So again, I need to go back and plug into the blue x plus 91. So I'm going to say, well, x plus 91, that is negative 6 plus 91, which is, what's that, 85? Yeah, 85, and we're talking about degrees. All right, there we are.